All right, so this is the key to to lines worksheet 1, and basically you just wanted to find the distance and midpoint of the segment that contains the following endpoints. And so you just had two problems here. And notice it did indicate simplify radicals whenever possible, and you must show work for the distance part. Okay, so notice the idea here is that I'm going to look at this in terms of your coordinate plane just to kind of give you an idea of what it is you're trying to do. But if I plot those 2 points here, negative 2, 3, so negative 2, so remember you start at the origin, you go 2 to the left, so here's negative 2, and then you go up 3. And so you can't see the little grid lines here, but negative 2, 3 is here. So there's the point negative 2, 3. And then the other endpoint, which is negative 1, negative 2, is, so you go to the left 1 and then down 2. So that one is about here. And so if you look at this segment, remember this is a segment, not a line. It's a segment. But if you draw this segment, and I'm doing this by hand, so it's not really straight. But if you draw this segment, what you want to do is find the length of that segment. So that's that distance. And then the next thing you want to do is find the midpoint. Remember, the midpoint is a point in the middle of that segment. All right, so if you look at this segment, where's that middle? So you know the middle is going to be, the midpoint is going to be somewhere in the middle, so around here somewhere. Okay, it's not going to be here because that's obviously not the middle of that segment. It's not going to be here. It will be somewhere around here. Okay, so that's what you're trying to find. Now, there are formulas to help you do this. And so the distance formula, just to remind you, the distance formula, and let me go ahead and do this here. So I'll write it on here. So the distance formula is the distance between 2 points is going to be the square root of, and then you're going to say x2 minus x1 squared, and then plus, and then y2 minus y1 squared. So remember x2, x1, y2, y1 are the coordinates of these points. So that's what those represent. So you subtract your x coordinates, square it, subtract the y coordinates, square it, and then add them up and then take the square root. So notice in one of the lessons you saw that this formula came from using Pythagorean's theorem. So that's where that came from. But there's the formula for finding the distance between 2 points. All right. And then the midpoint formula is going to be, and remember the midpoint's a point, so you have to list it as an ordered pair. So in that case, though, you're going to add your x coordinates together and divide by 2, and then add your y coordinates together and divide by 2. All right, so remember, and the reason you divide by 2 is because you're looking at the middle of a segment, so you divide into 2 equal parts. All right, but notice that distance involves, the formula came about or is derived from using the Pythagorean theorem, and then you have your midpoint. All right, so those are the formulas. So if we look at number 1, we have these two endpoints, negative 2, 3, that's a 3, and then the other one is negative 1, negative 2. Okay, what some students like to do is they like to label these points. So let's call this the first point, this the second point. And so we'll say this is the x coordinate of my first point, so notice the subscript, x sub 1. And then this will be the y coordinate of my first point. So remember, in an ordered pair, this is your x, this is your y coordinate. And then so this was my first point, and this will be my second point. So we'll call this x2 and then y2. And then we'll just take this information and substitute it into these formulas. So the distance then for number 1 will be the square root of, so you have to show this work, the square root of, and then all you do is subtract the x coordinates. So let's start with x2. Now, it did not matter, by the way, it did not matter whether you said x1 first or x2 first. It does not matter, because in the end, you're squaring it. All right, so it did not matter. Okay, so we're going to just go ahead and use this though. So we're going to say x2. So x2 in this case is a -1. Put that in parentheses. Subtract, that's what this says, subtract x1, and x1 here is a -2. So this is what it looks like so far. Then we're going to square that. Whatever that is, we're going to square it. Plus, and then for this one, you're going to say y2 minus y1. So y2 is -2. Put that in parentheses. Subtract, and then y1 is 3. And then whatever that is, we're going to square it. Okay? All right, now, some students and some of you here may still have trouble understanding how to deal with signed numbers. So just let me remind you, see that -1 subtract -2? Remember, one of the things you learned was that you can always change subtraction to an addition problem. In order to do that, though, you're going to add the opposite. So you have to take the opposite of that number. So this becomes -1 plus, and then the opposite of -2 is a +2. So -1 subtract -2 means the same thing as saying -1 plus 2, which is just a +1. Now, if you did not remember that, then just use your calculator. So you're just going to say, -1 subtract, make sure you use, well, let me just start this over. So you're going to say -1, so here's your negative button right here, -1, and then your subtraction button is right here. There's your subtraction button. Subtract, and then -2. See how that looks? So -1, subtract, and then the -2, and that's going to equal a +1. All right, so this expression here becomes a +1. Now, when you do the next step, you still have to say that square root. So make sure everything you write is mathematically correct. All right, so in parentheses, this -1 subtract -2 is a +1. You're going to square that, plus, and then do the same thing here. -2, let's think about this. -2 subtract a +3. That's what that means. And so changing the subtraction to addition, this becomes -2 plus the opposite of a +3, which is a -3. And then a -2 plus a -3 is a -5. And you can use your calculator, do that in your calculator. So you're going to say negative, let me clear this. So you're going to say -2 subtract 3, and notice you get -5. Make sure you put that in parentheses, because that -5, when I square it, it has to be a positive number, because you're squaring this number. So whenever you square a number, or whenever you raise a number to an even power, it's never going to be negative. So make sure you put that in parentheses, because if you didn't, and you use your calculator, you would probably indicate -25, but it's not, because -5 times itself is a +25. All right, so now what we're going to do is we're going to simplify each one of these. So you're going to say square root. You have to show that square root symbol. 1 squared means 1 times 1, which is 1, plus -5 squared means -5 times a -5, which is a +25. And then that's going to equal the square root of 26. And then besides the number 1, there's no perfect square that goes into 26. So you're done. You cannot simplify this. So there's the distance. So basically what you found is that this distance right here, that distance, is going to end up being the square root of 26 units, whatever the units are. All right? Okay, so that was the answer to number to 1, the distance. Now let's do the midpoint for this. So the midpoint, remember that's this formula here. So basically you're going to add the x coordinates together. Now remember, the midpoint's a point, so you have to put that in parentheses because it's an ordered pair. So x1 plus x2, so you're going to say x1, which is -2, plus x2, which is a -1, divided by 2, comma, and then do the same thing with the y's. 3 plus y2, which is -2, divided by 2. Simplifying this becomes -2 plus a -1 is a -3, so it becomes -3 halves divided by 2. And then 3 plus a -2 is 1, so this becomes 1 half. So there's your midpoint. And if you look at this, see that negative 3 halves 1 half? So negative 3 halves is negative 1.5. So look, so I'm going to go negative 1.5 to the left, and then 0.5 up, and then there's the midpoint. So that point right here is the midpoint of that segment. And the coordinates of that midpoint is what you just found. Negative 3 halves, comma, 1 half. And so that's what you found. So that's how you determine distance and midpoint using those formulas. Okay, let's look at number 2. So number 2, I'm going to go ahead and put number 2 here. I think I have enough room. So number 2, the endpoints are 3, 5, and the other one is negative 4, 2. So just like we did in the previous problem, let's go ahead and label these coordinates. So this will be x1, y1, and then x2, y2. And so let's do the distance first. So this would be the square root of. Now remember, you're going to subtract your x coordinates. So let's start with x2. So it will be negative 4 in parentheses, negative 4 subtract 3, and you're going to square that. So x2 minus x1. So that's what you see here. Plus, all right, so remember your work. You got to show that work. Plus, and then now you're going to subtract your y coordinates. So let's start with y2 in parentheses 2 subtract y1, which is 5. And whatever that is, we're going to square it. Now let's go ahead and simplify each of those parentheses. So it'll be the square root of negative 4 subtract 3. If you use your calculator, okay, you're going to get a negative 7. So that's negative 7 squared. Plus, and then 2 subtract 5. Again, just use your calculator. So remember the first one, I'm going to say negative 4 subtract 3. Notice you get negative 7. And then 2 subtract 5, you get negative 3. But hopefully you remember these how to deal with signed numbers from your previous experience. So you don't need to rely on a calculator for that. And it'll be negative 3 squared. Now let's go ahead and simplify this. And remember, whenever you raise a negative number to an even power, it's always positive. So remember, this number that's in parentheses squared should never be negative. So this becomes negative 7 times itself. Now, some of you may want to put that in a calculator. To put that in a calculator, you got to put that in parentheses. So you're going to say parentheses, negative 7, just like this, close the parentheses, and then raise it to the second power, and you get 49. So negative 7 times negative 7 is a positive 49. All right, so that's going to go here. And then you do the same thing with negative 3. Negative 3 times itself is 9, right? But if you want to verify that, you're going to say parentheses negative 3 has got to be put in parentheses. Then you're going to raise it to the second power, and you get a positive 9. Then we're going to add these up. 49 plus 9 will give you 58. Okay, so I get the square root of 58. All right, now at that point, you want to simplify this if possible. So we got to think about a perfect square other than 1 that goes into 58. So let's remind ourselves about these perfect squares. I'm going to go ahead and write that here. So perfect squares, and remember there are an infinite number of those. So the first one is 1, then the next one will be 4, then the next one is 9, the next one would be 16. So remember how I'm getting these, and there are an infinite number of those. So you're going to say 1 squared, 2 squared, 3 squared, 4 squared, and the next one will be 5 squared, so that's where we get this 25. Next one will be 6 squared, so that's where we get this 36, and so on. So those are your perfect squares. That's how you get those perfect squares, and there are an infinite number of those. It keeps on going. What we want to do, though, is determine, besides 1, because 1's a factor of every number, besides 1, are there any of these other perfect squares that go into 58? If so, I can simplify this. So let's look at 4. So let's see if 4, if 58 is divisible by 4. So we're going to say 58 divided by 4, and we get 14.5. So it's not, because I want this to be a whole number. So let's try 9. The next one's 9, right? Let's try 9 right here. So 58 divided by 9 is that. So it's not, because that's not a whole number. Now, at this point you can basically stop because if 58 was not divisible by 4, then obviously 58 will not be divisible by 16 because 4 is a factor of 16. All right, and you can check 58 divided by 16 is 3.625. All right, so at that point you realize, hey, I cannot simplify the square root of 58, so I'm done. All right, so there's your answer there for the distance. Now the midpoint, remember the midpoint's a point, so you have to put that in parentheses. If you didn't put in parentheses, you wouldn't get full credit. All right, so everything you write has to be mathematically correct. Okay, so for the midpoint, you're going to add the x coordinates together this time. So you're going to say 3 plus a negative 4, always divide by 2 because that's the middle, and then 5. So you add your y coordinates now, 5 plus 2 divided by 2. Simplifying this, 3 plus a negative 4 is a negative 1, so that becomes negative 1 half. And then 5 plus 2 is 7, so it becomes 7 halves. And simplify if you can. I cannot simplify this, and so there is your midpoint. So that is how you find the distance and midpoint of a segment. All right, so that is the answer to A and